Welcome to this research summary, where we break down key findings from a review by MacInnis and Gibala on how interval training influences physiological adaptations and why intensity matters. Let's start with the basics. Interval training includes repeated bouts of intense exercise followed by recovery. It typically falls into two categories: high-intensity interval training, HIIT, near maximal efforts, usually around 95% of your max heart rate. Sprint interval training, SIT, supra-maximal all-out efforts exceeding VO2 max. These methods are compared to moderate-intensity continuous training, or MICT, which involves steady-state effort at a lower intensity. Now, on to the big question. What kind of adaptations does interval training actually trigger? Both HIIT and SIT can improve aerobic capacity, VO2 max, and mitochondrial content, just like MICT, but there's more nuance. The review shows that higher intensities trigger greater cellular stress, activating key pathways for mitochondrial biogenesis. This means more and better functioning mitochondria in your muscles, which enhances fat oxidation and endurance. Studies cited in the paper found that just 6 sessions of HIIT or SIT can increase mitochondrial enzyme activity by up to 35%, with changes visible after just a few workouts. But here's where it gets interesting. When HIIT and MICT were directly compared in single-leg cycling experiments, HIIT produced greater gains in mitochondrial content, even when the total work was the same. That's because the intensity of effort seems to be a more powerful driver than duration or frequency when it comes to mitochondrial adaptations. What about SIT? Despite using much lower training volumes, SIT has been shown to induce similar mitochondrial and VO2 max improvements as MICT. This makes SIT a time-efficient alternative with comparable benefits, especially when time is limited. The researchers also examined capillary density, stroke volume, and blood volume, other important markers of cardiovascular health. Here, the evidence is less clear. Some data suggest MICT might be better for increasing capillarization, while stroke volume responses vary depending on the training volume and duration. As for VO2 max, intensity again plays a big role. Multiple meta-analyses cited in the review show that HIIT typically outperforms MICT in improving VO2 max, even when the training volume is lower. To sum it up, interval training, especially at higher intensities, is a powerful stimulus for improving aerobic performance. It's not just about working harder, it's about working smarter, leveraging intensity to spark rapid and significant physiological change. However, the full picture of how intensity, duration, and frequency interact remains incomplete. More research is needed to explore these variables, especially for long-term cardiovascular adaptations. Thanks for watching. If you're designing a training plan, remember, intensity matters, but so does the overall structure of your program.